After completing this section, you should be able to achieve the objectives shown on this slide. By demonstrating competence in Mstp, you should be able to understand how FortiSwitch provides a loop-free topology on multiple instances, while being backward compatible to legacy and third-party switches using STP and RSTP. STP and RSTP enable you to deploy redundant links in your LAN, while keeping the network loop-free. Although preventing loops is critical, it also results in a surplus of resources that could otherwise be used to support a higher throughput. This is addressed by Mstp, which is the spanning tree version that runs on FortiSwitch. Mstp, which is an evolution of RSTP and backward compatible with both of its predecessors, enables you to deploy multiple spanning tree instances, MSTI, and then map one or more VLANs to each MSTI. Because you can also set a different root bridge for your MSTIs, the instances can converge on different logical topologies. The result is that the instances can use alternate paths that would otherwise be blocked for all VLANs if using STP or RSTP. The physical topology shown on this slide has 3 interconnected switches and 2 VLANs. In STP and RSTP, the resulting loop-free topology would block the alternate path, which then forces traffic from both VLANs to be forwarded through the primary path, leaving the alternate path unused unless the primary fails. But with Mstp, you can configure 2 MSTIs, MSTI1 and MSTI2, set a different root bridge for each instance, and then map one VLAN to each MSTI. The result is that Mstp calculates 2 different logical topologies, each using a different path to the root. The 2 different paths enable you to use all existing network links, and therefore make more efficient use of your network resources, while still keeping the network loop-free. Also, although in the example a single VLAN is mapped to an MSTI, you can actually map multiple VLANs to an MSTI. This enables you to map multiple VLANs to a reduced number of instances. Finally, if you don't create additional instances, there is a default instance called Internal Spanning Tree, IST, which is assigned to MSTI0 on FortiSwitch, and that contains all the VLANs that haven't been mapped to other instances. Mstp is backward compatible with STP and RSTP. When you configure your switch to use Mstp, the switch must first figure out what kind of protocol the adjacent switches are using. Switches that have the same Mstp configuration for the following attributes are placed in the same region. Region name, a name you assign to the region. By default, FortiSwitch does not assign a name. Mstp revision number, a number that indicates your Mstp configuration version. The idea is to change the version number after you change the configuration. By default, FortiSwitch uses version 0. MSTI to VLAN mapping table. When you change the mapping, the table is updated. By default, all VLANs that haven't been placed in other MSTIs are placed in MSTI 0. By contrast, switches that have different Mstp configurations or are using STP or RSTP are seen as belonging to another region. Within an Mstp region, Mstp is used to calculate the logical topology for the different instances. At the region boundary, and depending on the protocol used by the adjacent switch, Mstp switch ports use STP or RSTP to calculate a common spanning tree, CST, topology that results in a loop-free topology for all regions. CST is just another way to refer to the single instance used by STP and RSTP to calculate a loop-free network for all VLANs. The physical topology shown on this slide has 4 interconnected switches. Switch 4 belongs to a different region than the one where the other 3 switches operate. Within the region of the 3 switches, Mstp calculates 2 different topologies, one for each MSTI. However, at the region boundary, there is only one topology, the CST of the network. You can adjust the global STP and Mstp settings for all managed switches or override them on individual switches. This slide shows the 40 OS CLI commands you can use to adjust these settings either globally or per switch. Note that some settings are relevant only to STP, and others only to Mstp. One setting that hasn't been discussed yet is max hops. In an Mstp region, the max hop setting defines the maximum number of hops that a BPDU sent by the root bridge can be forwarded in the region before it is considered expired, and therefore discarded by a receiving switch. When a non-root bridge receives the BPDU, the hop value in the BPDU decreases by 1 before the BPDU is forwarded to the next adjacent switch. If the hop value in a BPDU is 0 when a switch receives it, the switch discards the BPDU. By default, max hops is set to 20. The goal of this setting is to limit the size of the Mstp region. Mstp calculates a loop-free topology for each instance, from the perspective of the root bridge on that instance. Because Mstp is based on RSTP, the same rules used by RSTP for root bridge and port rule election are used by Mstp on their instances. The port states and default port costs are also the same. In addition, instances also benefit from the rapid transition on full duplex links and edge ports supported by RSTP. The information of all instances is sent from the IST, MSTI0, using Mstp BPDUs. The Mstp BPDUs are essentially RSTP BPDUs, except that they also include additional fields, called mRecords, that carry Mstp-specific information, such as the Mstp region name, the configuration version, and the MSTI to VLAN mapping table digest. Note that BPDUs don't contain the actual MSTI to VLAN mapping table, but only a digest computed from it. The mRecords also carry MSTI-specific information, such as the local bridge ID, instance root bridge, and instance root path cost. The MSTI-specific information is then used by Mstp switches in a region to calculate topologies for each instance. You can configure up to 16 instances on 40 switch, MSTI 0 to 15. MSTI 0, IST, is the default instance and cannot be deleted. Each MSTI elects its own root bridge. You can control the instance root bridge election by adjusting the bridge priority on that instance. The administrator can also control the role of a port by adjusting the port cost and priority on the instance. This slide shows the 40 OS CLI commands to create instances, set the bridge priority for an instance, and change the cost and priority on a port. Note that the port cost and port priority settings are available on the 40 switch CLI only. Switches that have different Mstp configurations or are using STP or RSTP are seen as belonging to a different region. The interconnected regions then calculate a CST for the whole network. Each region elects a regional root bridge on the IST, MSTI0, that competes with other regional root bridges, different Mstp regions, or legacy switches, STP and RSTP switches, for the CST root bridge. The CST root bridge and port roles are elected using the same rules defined in STP and RSTP. The switch port in an Mstp region that connects to another region is known as the boundary port and participates in the CST calculation. If the adjacent switch on a boundary port is an Mstp switch or an RSTP switch, both switches use RSTP for CST convergence. If the adjacent switch is an STP switch, STP is used. The Mstp region sees the adjacent switch connected to its boundary port as another region. By contrast, the adjacent switch, switch 4 in the example, sees the whole Mstp region as a single switch. Switch 4 does not know anything about the internal instances on its neighbor, nor does it care. CST calculates a loop-free topology only on the links that connect the Mstp regions and legacy switches. The example on this slide also shows a CST topology. A new port role, the master port, is also shown. The master port is the boundary port in an Mstp region that connects to the best path to the CST root bridge. A master port is like a root port, except that it connects to a different region. In the example shown on this slide, switch 4 is the CST root bridge. The best path to the CST root bridge is over the link between switch 1 and switch 4. For this reason, the port on switch 1 that connects to switch 4 becomes the master port. Also, the alternate path between switch 3 and switch 4 is blocked. Note that the master port role is seen when Mstp operates with outside regions only. In most managed switch deployments, FortiGate is the focal device in the network because most of the traffic is usually destined to FortiGate, switch management traffic, or networks behind FortiGate, such as the Internet VLANs, and the corporate WAN. Given that FortiGate is the focal point in the network, it is convenient to have instances converged towards FortiGate by default. To accomplish this, the following Mstp settings are automatically changed in a managed FortiSwitch virtual stack. Bridge priority, the bridge ID on non-multi-chassis link aggregation group, non-MC lag, peer switches directly connected to the FortiGate FortiLink interface is reduced to 24,576. Default priority is 32,768. If the switch is an MC lag peer, the bridge priority is reduced to 20,400 instead. If there are multiple switches directly connected to FortiGate, the switch with the lowest MAC address becomes the root bridge. In addition, the bridge priority on downstream switches is reduced to 28,672, so they don't become the root bridge. Port cost, auto ISL trunks are assigned a cost of 1. Because auto ISL trunks can be formed only when one of the adjacent switches is in managed mode, the trunk is likely to be the shortest path to FortiGate. Therefore, it is convenient to reduce its cost, so it becomes the preferred path to the root bridge. Instances. By default, only one instance, MSTI0, is created on FortiSwitch. However, when FortiSwitch is authorized, another instance, MSTI15, is created for management traffic. The instance is mapped to VLAN 4094, which is the switch management VLAN. Having separate instances for user and management traffic enables the administrator to adjust instance 0 settings, in case the user traffic must converge on a device that is not the switch controller, without impacting the management traffic on switches. Note that the bridge priority and port cost changes are applied on both instances, 0 and 15. You can run the command shown on this slide to display spanning tree information for a specific instance on a managed switch. If you specify the instance number, FortiGate pulls information for all instances. The example shown on this slide displays information for instance 0 only, also known as the CST when referring to Mstp operation outside a region, or IST when referring to Mstp operation inside a region. Note that the IST route is also the regional route. The regional route competes with other regional route bridges for the CST route bridge. The output also displays the STP timers configured on the region. The timers are displayed for instance 0 only, because the other instances inherit the same timers. This slide shows a continuation of the previous output. The output shows the port information section of the interfaces that participate in the Mstp instance. An interface, which can be an individual switch port or a trunk, participates in an instance when the interface belongs to one or more VLANs that are mapped to that instance. For each port, the output indicates its cost, priority, role, state, and hello time. There is also a flag column that provides further information about the port, such as whether the port is configured as an edge port, or whether it triggered STP enhancement features, such as BPDU guard or loop protection. Good job. You now understand Mstp. Now, you will learn about spanning tree enhancements.